Hello, in this video we will talk about the product of two complex numbers. Previously we had done the product of two complex numbers, but this time we will convert our complex number into polar form, and then we will do the product of both of the complex numbers. Suppose you have two complex numbers. The first one is z1 and the second one is z2. These are the two complex numbers in the Cartesian form, but we have to first convert into the polar form or trigonometric form both of the complex number. We need in the trigonometric form, just like we did in the couple of videos ago. So we will convert them into the trigonometric form, then we will multiply them. Okay, suppose that the trigonometric form of z1 is r1 cosine theta 1 plus iota sine of theta 1, and similarly the trigonometric form of z2 is equals r2 cosine of theta 2 plus iota sine of theta 2. Okay, you can visualize this thing as in this way. Suppose you are in a complex plane and the first complex number z1 is here is z1, and suppose here is z2. Okay, so this one is a plus bi, which is z1, and this is c plus di, which is z2. Okay, since this z1 has some radius, call that this radius is r1. Suppose that this radius is r2, and both of the complex numbers have some specific angle with the x-axis along the positive direction. Suppose z1 makes angle of theta 1 along the positive x-axis, and z2 makes angle of theta 2. So in this way you can write z1 is equal to, for the z1 the radius is r1 and cosine of the angle plus I sine of the angle. Since the angle is theta 1, so therefore the polar form or the trigonometric form of z1 is this one. And similarly z2, you can check, the radius of z2 is r2, so therefore I have written r2, and it makes angle theta 2 along x-axis. This angle, it makes theta 2, so therefore I wrote cosine of theta 2 plus iota sine of theta 2. So these are the two polar forms of the complex numbers. Now we claim that when you make the product of z1 with z2, then the product of z1 and z2 is the product of the radii, r1 times r2 into cosine of the angle theta 1 plus theta 2 plus iota sine of theta 1 plus theta 2. This is their product. This we have to prove. Okay, so what are the assumptions? The assumption is the polar form of z1 is this one and the polar form of z2 is this one. Then their product has this polar form. Okay, what is the product? The product is obtained just by simply multiplying the radii and adding the angles and putting into the cosine and sine in this form. This is called Euler form of the complex number. So this is what we have to prove. So here is the proof. This is our assumption and this we have to prove, okay? So suppose Z1 is R1 times cosine of theta 1 plus iota sine of theta 1, and Z2 we have assumed R2 times cosine of theta 2 plus iota sine of theta 2. Then we need to prove that Z1 times Z2 is equal to this. This we have to prove, okay? So we will calculate this thing. Z1 times Z2, put their values. Since Z1 is R1 times this thing, so I will plug this value of Z1, and then I have to plug this value of Z2 because I have to take the product. So the product is Z1 times Z2. So I will plug their values. Now we have both values here. Now if you multiply R1 with R2, so you get R1 times R2. Okay. Now you have this product and this product. You have these two factors. So let me write these factors first. Times cosine of theta 2 plus iota sine of theta 2. Okay, now if I multiply, R1 and R2 are same, are as it is. You have to multiply cosine of theta 1 with this one and then this with this one. So first of all, multiply cosine of theta 1 with cosine of theta 2. So you will write cosine of theta 1 times cosine of theta 2, okay? Now you have to multiply this with this thing. So what is that? This is I, so you can write I here, times cosine of theta 1, sine of theta 2. Cosine of theta 1, sine of theta 2. This is done. Now you have to multiply this thing with both, plus I sine of theta 1 times cosine of theta 2. Now you multiply this thing with this one. So you have I square because I is 2 times. I square sine theta 1 sine theta 2. Okay. Sine theta 1 sine theta 2. Okay. So this is the product which we have written here. R1 times R2. We have to rewrite these whole things because this I square is always minus 1 because we know the I square is minus 1 because it's a complex number. So I will replace I square by minus 1. Okay, so let me write first cosine of theta 1 cosine of theta 2. You know these two terms, this one and this one, has I common in both, so I can take common I in both. Inside I will have this term and this term because I is common, so I have written I outside. Inside I will write this thing and this thing. Okay, so what is this thing? This one is cosine theta 1 sine theta 2, and this thing is equal to sine theta 1 cosine theta 2. Okay, and this I square is minus 1, so here I will write minus sine, this thing is sine theta 1 sine theta 2. Now we will first write the real part and then we will write the imaginary part. R1, R2, real part without I. This number is without I. This number is without I. So I will write these two terms first. Cosine of theta 1, cosine of theta 2 minus this thing, sine of theta 1, sine of theta 2, plus I'll write this I times cosine of theta 1, sine of theta 2. Okay, so first of all I will write this term, then I write this term. It doesn't matter because a plus b is equal to b plus a. It doesn't matter. Here you have plus, so you can write this term first and this term later. So you can write sine theta 1 cosine theta 2 plus cosine theta 1 sine theta 2. Okay, this is, we have rearranged, right? Now if you check my previous video, we have proved in the previous video that from previous video we have proved that cosine of theta 1 plus theta 2 was equal to cosine of theta 1 cosine of theta 2 minus sine of theta 1 sine of theta 2. And from the same video you have sine of theta 1 plus theta 2 equals sine theta 1 cosine theta 2 plus cosine theta 1 sine theta 2. Okay, if you look, this term and this term are the same. Okay, so since this term is equal to this term, therefore I can write here, in place of here I can write this value, cosine of theta 1 plus theta 2, because this term is equal to this term. Therefore here I can write cosine of theta 1 plus theta 2, and this term is sine theta 1 cos theta 2. I mean here sine theta 1 cos theta 2 plus cos theta 1 sine theta 2. Okay, so that means this term and this term are the same. So therefore here I can replace this value. Okay, so if I plug these values here in this equation, both of the values, I'll get z1 times z2 equals r1 times r2. So here I will plug this value, which is cosine of theta 1 plus theta 2, okay, and plus I as it is, I will write plus I, and here I have to plug this value, okay, which is sine of theta 1 plus theta 2, and this is what we have claimed previously, and here we have proved it. Okay, hence proved. Now we do an example. In this example you have z1 and z2. You know z1, in this z1 the radius r1 is 2 and theta 1 is 30 degrees, right? And in r2, in z2, our radius r2 is 3 and theta 2 is 135. Okay, so we have to find the product. So in this example we are asked to find z1 and the z1 multiply z2. Here is the proof. here is the solution. Since by theorem Z1, Z2 is equal to R1 times R2 cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. Since radius 1 is 2 here and radius 2 is 3, so I will write 2 times 3 cosine of, what is theta 1? Theta 1 is 30 and theta 2 is 135. So I will write 30 plus 135 plus I, here also 30 plus 135.